Good afternoon, students. Today we will discuss about the isomerism exhibited in coordination compounds. What is isomerism? The isomers will have the same molecular formula, but they will have different structures because of the ligands or molecules. Okay, and they will have different physical and chemical properties. Okay, the coordination compounds classified into two, that is the isomerism classified into two major category. One is structural isomerism and another one is stereoisomerism. Structural isomerism further classified into ionization isomerism, hydride isomerism, coordination isomerism, linkage isomerism, and coordination position isomerism. Okay, now we will discuss about structural isomerism. The ionization isomerism is exhibited in the compounds in which the different ions are present in the solution. See here, CONH3 5 times BrSO4. The compound can exhibit in two forms. One is COBrNH3 5 times. It is placed inside the coordination sphere and sulfate is existed as ion. When it is treated with barium chloride solution, we will get red violet color and it will be dissociated as COBrNH3 5 times 2 plus, and it is a complex ion and it is the ion which is soluble in the solution. This is the primary valency and these are all ligands which is said to be the secondary valency, and it denotes the coordination number, and the sulfate ion will indicates the oxidation state as per the Werner's theory what we have discussed earlier. Okay, in the case of this one here, bromine will be present in the solution. When it is treated with silver nitrate, it will produce red color, and when barium chloride is treated with this, barium sulfate will be precipitated and here silver bromide will be formed. Okay, and other examples are given here. Here in this case, in first one nitrate ion is present in the solution, and here chlorine is present in the solution. The sphere will be like this. That is one of the chlorine is replaced by NO2. Okay, and here in this case bromine is placed outside the sphere, that is it will be present in the solution. Here in this case chlorine is present in the solution. Okay, and the second one, hydride isomerism. This is arised due to the replacement of coordinated group by water of hydration, that is see here hexaquachromium 3 chloride. In this case the water molecule is replaced by chlorine. Here one of the water molecule is replaced by chlorine, so instead of chlorine, water is present in the solution. Okay, here Cl2 should be there. And here in this case 2 of the water molecule is replaced by chlorine. See here, instead of 2 chlorine, 2 water molecule is present outside the sphere. That is, the number of water molecules replaced by some other ion. It is said to be hydride isomerism. And how we will conclude the number of ions present outside the solution. When it is treated with concentrated sulfuric acid, it does not lose water. That is, outside the sphere there is no water molecule. and 3 chloride ions are precipitated with silver nitrate. We have discussed in Werner's theory also. Here 3 chloride is there, so when it is treated with silver nitrate we will get 3 chloride ions because the chlorine is present outside the sphere. Here in this case 2 chlorine is there, so it will give 2 chlorine ions with silver nitrate solution, and 1 water is there. So losses of water molecule will be taken place when it is treated with concentrated sulfuric acid. Here in this case 2 chlorine molecules are there, sorry 2 chloride ions are there, so it will be precipitated with silver nitrate and it will loses 2 water molecule, and when it is treated with concentrated sulfuric acid. Okay, here also printing mistake is there. 2 water molecule. Okay, and one more example is given here. What about coordination isomerism? Here the compound compromising of both cationic and anionic complex. See here, this one is neutral compound and this one is anionic complex. So these are compromising by exchanging the central metal atom or ligands. Here just see, here hexamine is present, here hexacyano present, here just the central metal atom is exchanged. Okay, in the next case again tetraamine tetrachloro ion is present here, so here copper and platinum is gets exchanged, that is the central metal atom is getting exchanged. And further 2 more examples are given here. Next, linkage isomerism. If the donor has more than two atoms as the donor means they can exhibit linkage isomerism. That is, if we consider nitro group means one compound will be exhibit due to nitrogen if nitrogen acts as the donor. In another case oxygen will act as the donor atom. So that is one compound is exhibited due to the nitrogen linkage with central metal atom and the other one is due to the linkage of metal oxygen bond. Okay, see here in this case nitro group is, that is nitrogen is directly linked to cobalt atom, so it will be termed as pentamine nitro N-cobalt chloride. Here again this one is wrong. Nitro NO2 group means nitro N-cobalt 3 chloride. Here in this case the cobalt is linked with oxygen atom, though it has the same molecular formula, but the linkage is through nitrogen over here. Here in this case linkage is through the oxygen, so it should be named as nitrito. So again pentamine nitrito cobalt 3 chloride, because 2 chlorine is present outside the sphere and one negative ligand is present here, so 3 chloride. Okay, and the other examples for the linkage isomerism, cyano. Here the linkage will be through the carbon and here in this case isocyano nitrogen. Here in thiocyanate carbon will be the nitrogen will be the donor atom, and here in the case of isothiocyanate sulfur will be the donor atom. And coordination position isomerism, look at here the cobalt is linked with 4 amine ligand, here in this case 2 amine ligand and 2 chlorine ligand. The distribution of ligand will be differ, that is the position of the ligand will be changed. See the next one, that is here 4 amine is there, here 2, totally 6. Here 2 chlorine is there, so equally 1 chlorine should be placed here, and if one amine is distributed here means what will happen, see here NH3 3 times and 1 chlorine, CONH3 3 times and 1 chlorine. So this is said to be, that is why it is differently placed relative to the cobalt atom, relative to the central metal atom. That is, it is exhibited in bridged complex and results from the different placements of the ligand. Okay, next we will discuss about stereoisomerism in next class.